Today we are starting with the numerical problems from exercise 2B for class 9 physics. Before going through these numerical problems, I have sent 4 videos on a graphical representation which you must watch before solving this. Otherwise you might not understand this numerical problems. So if you haven't gone through those videos, so first of all go through those videos and then come back to this video. So going to number 1, please refer your textbook for the question. It reads as figure 2.37a shows a displacement time graph for the motion of a body. Use it to calculate the velocity of a body at t equals to 1 second, 2 seconds and 3 seconds, and then draw a velocity time graph. So here basically a displacement time graph is given. From the graph we see that the line is making an acute angle with the x-axis, and then from this graph we are supposed to find a velocity time graph. So I have done this here. Please refer your textbook for the question. For t equals to 1 second, displacement is 2 meter. How do you get this 2 meter? It's very important how to get this 2 meter from the graph. For time equals to 1 second, displacement will be 2 meter. So time equals to 2 seconds, the displacement will be 4 meter. For time equals to 3 seconds, the displacement will be 6 meter. So using these values, I have to calculate the velocity 3 times for every time given to us. So for the first time which is given to us, which is 1 second, so if t equals to 1 second, then s equals to 2 meter from the graph, and then using the formula for velocity, which is displacement by time, I'm getting 2 meter per second. Similarly, for t equals to 2 seconds, displacement will be 4 meter, and using the velocities formula, which is again displacement by time, I'm again getting 2 meter per second. And similarly, for time equals to 3 seconds, I have calculated velocity as 2 meter per second. So every time we see that the velocity's value does not change, which means it is a uniform velocity. So using these values, I am supposed to draw a velocity time graph. So for 1 second, my velocity is 2 meter per second. For 2 seconds, the velocity is 2 meter per second. For 3 seconds, the velocity is 3 meter per second. So we are getting 3 dots here. If we join those dots, I'll get a straight line for 1. Since zero's value we don't have to calculate, but since it is uniform, I can draw a straight line from the y-axis also. So this is how it is done. This is the answer of number 1. Now we can go to number 2. Please refer the book for the question. Following table gives the displacement of a car at different instants of time. For 0 seconds, the displacement is 0. For 1 second, the displacement is 5. For 2 seconds, the displacement is 10. For 3 seconds, the displacement is 15. And for 4 seconds, the displacement is 20. Using these values, I am supposed to draw a displacement time sketch and then find the average velocity of the car from the graph itself. And number B, what will be the displacement of a car at 2.5 seconds and 4.5 seconds from the graph. So let us go to the solution. I have done a graph on the blank paper. You might use a graph paper, or you can do on the blank side of your exercise book or on the rule side of exercise book. It does not make any difference, but make sure you take the measurements equal from here to here. That's I have taken 1 centimeter. You can take 2 centimeters, 3 centimeters, depending upon your convenience. So while drawing the graph, this is my time axis and this is my displacement axis. So I am starting with the origin. The time given to me was 0, 1, 2, 3 and 4. I put 1 extra 5 in case if we need. Then on the displacement side it is 0, 5, 10, 15, 20. Again, in case if we need, I have used 1 extra value also. So now plotting the graph. I hope you know how to plot the graph. So for 0 is 0, so I get a dot here. For 1 second it is 5 meter. For 2 seconds it is 10 meter. For 3 seconds it is 15 meter. For 4 seconds it is 20 meters. So I'm getting these dots. So when I join these dots, I'll get a straight line. This is how my graph looks like. So this is the first part of question number 2a. From this graph, I am supposed to find the average velocity. So to find the velocity from displacement time graph, I am supposed to find the slope of the graph. And I hope you know how to find the slope of the graph, because we have done this while we are solving simple pendulums graph. So to find the slope of the graph, so I have to choose random 2 points on the graph. I have chosen these 2 random points on the graph. So if I have taken this point, for this point my displacement will be 17.5, which is between 15 and 20. And if I drop a perpendicular on the x-axis, I'm getting a point between 3 and 4, which is 3.5. So these are my values of S2 and T2. Now I'm supposed to find the lower values, which is S1 and T1. I've chosen this point here. For this point, if I drop a perpendicular on the y-axis, I'm getting a value of S1, which is between 5 and 10, which is 7.5. And then again, dropping a perpendicular on the x-axis, I'm getting a value between 1 and 2, which is 1.5. Now replacing these values in the formula, which is S2 minus S1 upon T2 minus T1. Well, after solving this, we get the answer as 5 meter per second. Please do the calculations. Now the next part, which is 2b, the time given to us is 2.5 seconds. For this time, for this given time, the question is asking us what will be the displacement. So 2.5. See, we don't have 2.5 on the graph, so that should be in between 2 and 3. So somewhere around here. So if I go here and then drop a perpendicular here, we'll get a value between 10 and 15. Exactly in between 10 and 15 we'll get 12.5. And then number 2, which is at t equals to 4.5 seconds, and number 2 at t equals to 4.5 seconds, doing the same thing between 4 and 5, 4.5, somewhere around here. If I go here, it goes up till here, and that should lie between 20 and 25. So between 20 and 25, again I am getting 22.5 as my answer. This is number 2.